This is section 2-6, special functions. Our objective today is I can write and graph piecewise defined functions and absolute value functions. A function written using two or more expressions is called a piecewise defined function. A circle indicates that the point is not included in the graph, and a dot indicates that the point is included. So I've given a little example down here. You guys have seen this before. When we're looking at something where it's just greater than or less than a number, we know that if we were going to graph that on a number line, it would just be an open circle on 6 and shade to the right. Now the important part that's going to help us today is that we know it's an open circle. So anytime you see a greater than or less than, we're going to have an open circle. If we have something like x is greater than or equal to 6, we know it's going to be a shaded in circle on 6. And this is the important part here as well, is that greater than or equal to or less than or equal to, we're going to have a closed circle. In example 1, we're looking at a piecewise defined function and we're going to graph it. And we're going to tell the domain and range. Now, I wanted to just show you guys that the check your progress here actually goes with this graph. So this graph you won't actually be doing anything with in your notes. It was just on there for my in-class notes. So going ahead and looking at this, graph f of x equals x minus 2 if x is less than negative 1, and x plus 3 if x is greater than or equal to negative 1. So what we need to do, first we're always going to want to look at these boundaries. So in this case, there's only one boundary at negative 1. It's really important that we go ahead and show that boundary so that we know, okay, I can't draw past that. And we always draw our boundary with just a little dotted line, and that's just going to serve as a reminder for us that that's a boundary. So looking at the first piece of the piecewise, we have x minus 2 if x is less than negative 1. That means we're going to be looking at values that are over here, values that are less than negative 1. So let's go ahead and create a quick t-chart for that one. I'm going to label at the top that we're doing x minus 2 for this one. And when we create this, we always want to start with whichever value they gave us. In this case, they gave us negative 1. So we want to start with negative 1. And since these values are going to be less than negative 1, we want to choose a couple other values that are actually less than negative 1. In this case, I'm just going to choose negative 2 and negative 3. You could choose negative 5, negative 8, whatever you wanted, but these are going to be the simplest. So then finding our y, we know we'd have negative 1 minus 2, which is going to give us negative 3. We'd have negative 2 minus 2, which is negative 4. And negative 3 minus 2, which is negative 5. Now I can go ahead and graph these. What I need to be careful with is on that first point, negative 1, negative 3, since x is less than negative 1, that needs to be an open circle on negative 1, negative 3. So that's going to be right here on our graph. We want to make sure we leave that as an open circle. And then let's go ahead and graph our other points. So we have negative 2, negative 4, and negative 3, negative 5. And so this is a good idea of what our graph is going to look like. We can go ahead and connect these lines. But we do want to make sure we don't go past that boundary. That boundary is there for a reason. We cannot pass it. So that's the first part of our piecewise. Let's look at the second piece. We're going to have x plus 3 is that second piece. Again, I'm going to create a t-chart, table of values. And again, the boundary is negative 1. So I do want to include that negative 1 as my first number. And since these values are going to be greater than or equal to negative 1, we want to include values that are bigger than negative 1. So I'm just going to choose 0 and 1. We can go ahead and plug those in to get the y value. So we have negative 1 plus 3, which is 2, 0 plus 3, which is 3, and 1 plus 3, which is 4. When we go to graph our first point, negative 1, 2, we want to make sure that because this is greater than or equal to, that's going to be a closed circle on negative 1, 2. So go ahead and create that closed circle and then we'll graph our other points. So we have 0, 3, and 1, 4. And again, we can go ahead and create a line, making sure we don't cross that boundary. Now we also need to tell about that domain and range. So remember, the domain is talking about all of the x values. So when we go to talk about domain, we want to know which x values are covered here. So we want to say, okay, does it go all the way to the right? Well, yeah, it does. It's going to keep going this way and to the right forever. So it's going to take care of all of our positive y values, or all of our positive x values. And then does it go to the left forever? Well, yeah, it's going down and to the left forever, so it's taking care of all of those. Since there's a closed circle here, we know that -1 is also taken care of. So the domain on this is going to be all real numbers. When we talk about the range, remember we're talking about the y values. Now we know that he does go up forever, so it's taking care of all of these y values up here. We also know that he goes down forever, so it's taking care of all of these y values down here. However, you can see here, there's this gap in between that isn't taken care of, and we have to denote that. So the way that we're going to denote that here, we're going to say that y is going to be greater than, and let's take a look at what this is. Y in this case is going to be greater than or equal to, because it's a shaded in circle, +2. So we're going to say y is greater than or equal to 2. And then we also have to look at the other end of things. So we're going to say or, and then down here we have to take care of these values. We have to talk about these. So remember, this is an open circle. So we're going to say that y is less than, not equal to, because that's not a shaded in circle. And then that value is going to be, looks like, -3. You can also see piecewise functions that have 3 parts to them. In that case, there's going to be more than one boundary for them. So on this one, they want us to write the piecewise defined function that's shown in the graph. So we're actually working backwards from example 1. So we know we're going to have 3 parts. So we're going to go ahead and say f of x equals, and remember, f of x is just another term for y. F of x is representing a function. And we know we want to leave enough room for 3 different pieces, because we're going to have 3 pieces here. So first, let's go ahead and look at our first segment. Let's look at this dude way over here. So we can see that there's going to be a boundary right along here at +1. We can also go ahead and look at the second boundary, and we know that that's going to be at +2. I'm going to just go ahead and mark those. So for the first one, we see that the value is going to be if x, and we can see that it's going to be less than 1 and not less than or equal to, because it's not shaded in. So it's going to be if x is less than 1. Now we actually want to write the equation of that line. Now there's a few ways you can do this. You can pick a couple of points to figure out the line. We can also just pick the y-intercept and the slope and write it in slope-intercept form. So that's what I'm going to go ahead and do. I'm just going to go ahead and say we know that the y-intercept here is going to be +3. So we know we're going to have +3. And we know that our equation is going to have an x up here, and then we need to find the slope, because remember, our standard form is y equals mx plus b. So b is that y-intercept, and m is the slope. So if we look at the slope, we can figure out rise over run if we find 2 very clear points. And right here is a very clear point at -1, 1. And then here is a very clear point as well at 0, 3. And if we look, we're going to count up 1, 2, and over 1. So 2 over 1 is the slope, or just 2. So 2x plus 3. Looking at our second segment, this little dude that's right in between them, we have to mark that in our piecewise function. So we know that x is going to be in between something. And we can also see that these are both closed circles. So we know that x is going to be more than or equal to the value of 1. And it's also going to be less than or equal to the value of 2. And that's just looking at our two boundary lines that we have and looking at those being closed circles. So we know we're going to have the line underneath. Now I need to actually be able to write the equation of this line. And so if we take a look at this, we do need to know the y-intercept still. But there is no y-intercept because they had to stop for the boundary. However, if we continued to draw this line, the y-intercept would clearly be at 2. So we know that it's going to be plus 2 for that y-intercept. And then we want the slope. And these are two clearly defined points, and we're working down 1 over 1. So we know our slope is just going to be negative 1x. You can also just put negative x if you'd like. Taking a look at the third area, we know that in this case, nothing goes past this boundary of 2. Everything's greater than this x value of 2. So we're going to mark x is greater than 2 in this case. No line underneath because it is an open circle. And when we have a line just going straight across, we know that y is going to be equal to just a value. So in this case, y is going to be equal to 3. So we're going to mark that as f of x equals 3 if x is greater than 2. So looking at our real-world example, we're looking at an automotive repair center charging $50 for any part for the first hour of labor and $35 for any part of each additional hour. Now this is pretty standard if you go to have your car worked on. They're going to charge you pretty much a flat rate. So that means if they work on your car for a half hour or for 58 minutes, so 30 minutes compared to 58 minutes, they're going to charge you that same amount. So if we look at this, this is actually going to be a step function, which is a type of piecewise function. And we have to figure out how much they're going to charge us. So we know for the first hour, between 0 and 1 hour, so if x is in between these dudes, up to 1 hour, they're going to charge us $50. And then we have to think about each additional hour and what that means. So if it's between 1 hour all the way up to 2 hours, so x is going to be in between 1 and 2 hours, we know they're charging us the 50 plus a 35, which is going to give us a total of $85 that they're charging us. Then if we look at x being between 2 and 3, we know that they're going to charge us the $85 plus another $35 for that next hour, which is $120. And then if we want to look at another example, we'd say, okay, between 3 and 4 hours, what if they're working on my car that long? We're going to take the $120 and add another $35 to get $155. So you probably get a pretty good understanding of how this is going to work. Over on our axis, I use the x values as the hours working because that's our dependent variable, or our independent variable. The dependent variable, so it depends on the x, is how much I'm getting charged. They're charging me based off of the number of hours they're putting into my car. So, if we go ahead and take a look at this, we have between 0 and 1, and we're going to need to graph this, and it's a flat rate of 50. So how we're going to write this, we're going to go all the way up to 50 on our y-axis, and we're going to stay between 0 and 1 on the x-axis. So if we go ahead and look at that, now I made the y values count by 20s. So we have 20, 40, 60, 80, 1, all the way up to 180. So if I look at 50, which is the amount of money they're charging me, that's going to be between 0 and 1. So if I find 50, which is about right here on my graph, then that's what I'm going to be drawing. So I'm actually going to show you down here because it's going to give me more room to work where you can see it more clearly. So if I have 1, 2, 3, 4 hours. And then just so you can see it clearly now, I wouldn't really label my graph that I was using this way, but just so you can see it more clearly, I'm just going to write the numbers that we're using. So we're using 50, we're using 85, we're using 120, and we're using 155. And this is just so you can see what's actually going on with this. So between 0 and 1, we know that it's going to be $50, and we know that there's going to be an open circle on 0, and then on 1, it's going to be a closed circle. But it's a flat rate of 50 that whole time, so it's just going to be a flat line in between the two. Then we know if it's between 1 and 2, it's going to be up to 85, but it's going to be an open circle on the 1, all the way over to 2 where it's a closed circle. And step functions are always going to look like this. They're always going to look like a set of steps. Between 2 and 3, we're all the way up to 120. It's an open circle on the 2, a closed circle on the 3, and a line over. And then the same thing for between 3 and 4. So that gives you a clear view of what that's going to look like. In example 4, we're looking at an absolute value function. Now, something really important about absolute value functions is that they're always going to make a v. So you can remember value starts with a v, and these are always going to make a v. And you'll need to know that. And we'll do a lot of absolute value functions. So when we're looking at this, we're going to need to create a t-chart. So if I create a t-chart, my standard values that I'm typically going to use, since I don't know much about absolute value functions yet, I'm going to use -2, -1, 0, 1, and 2. And then I'm just going to plug those values in to get my f of x value or my y value. So I'm going to have 2, absolute value of 2 times -2, closed absolute value, minus 4. Same thing here. 2 times -1, all in absolute value, minus 4. Then absolute value 2 times 0, minus 4, and so on and so forth. So if I evaluate these, I have 2 times -2, which is -4, but the absolute value of -4, remember that's the amount it is away from 0. -4 is only 4 away from 0. We always want to make that a positive. So we'll have positive 4 minus 4, which is 0. So -2, 0 is going to be our first value, and I'm going to go ahead and plot that. Looking at our second one, we have 2 times -1, which is -2, but the absolute value of -2 is positive 2. So we have 2 minus 4, which is equal to -2. So at -1, our value is -2. Looking at 0, the absolute value of 2 times 0 is 0. 0 minus 4 is -4. So we'll go down even further to 0, -4 for our point. Then for 1, we'll have the absolute value of 2 times 1, which is 2. And 2 minus 4 is going to give us -2. And then for positive 2, we'll have 2 times 2, which is 4. Absolute value of 4 is 4. 4 minus 4 is 0. So as you can see, this one does make a nice V for us. We don't have to do any more points. Now, one mistake that I saw a lot in my class is that some people, if they did the points and it didn't create a V, they would just draw a line. But that's not correct, because like I said before, the absolute value function is always going to be a V. So that means you would need to use some other values. So maybe you'd try -3 and -4, or +3 and +4 to make sure that it created a V. So now we need to talk about the domain and range. The domain of an absolute value is super easy because it's always going to be all real numbers. It goes to the right forever, and it also is going to go to the left forever and ever. So then we need to look at the y values. Now, these go up forever, so we know that all of these y values up here all the way up to infinity are taken care of. However, none of these y values down here are ever going to be spoken for. They're never going to have a point that goes with them. So when we're talking about range, we're going to say y, because we're talking about the y values. And in this case, since the values are bigger than, they're going up, we're going to say greater than or equal to, And we can see that that lowest y point is right here, all the way down at -4. So we're going to say that y is greater than or equal to -4.